So today we are going to discuss about the algorithms which will be used for the implementing the distributed shared memory. Of course, we have four algorithm for that particular purpose. One is central server algorithm, then migration algorithm, then we have a read replication, and the last one is the full replication algorithm. And all these algorithms are based on a certain issues which are the central to the distributed shared memory, and that is to how to maintain the records, how to maintain the location, how to track the location of the remote data. Second one is if the data has to, or the block has to be moved from one place to another place, there may be a communication delay. There will be certain overheads which are related with the communication protocol, how to meet that. And then if two or more nodes or the processes wants to access the data which is available at the different nodes, and they want to access, how they can be done concurrently. So the first uh, algorithm is the central server algorithm. As the name states that in this algorithm, there is a central server who will be associating with all kinds of clients, and uh, and making its services available as per the request, whether it is a read request or it is a write request. So as the name says that it is a central server algorithm, so there is a central server uh, whose purpose is to maintain all the shared data. And whenever any read request is arriving from the different nodes, it will be returning that data items to them. If there is any write request, then the write request will be updating the data. Of course, all these things which is being happening, it is happening on the server side itself, depending upon the request of reading or writing, whatever is being done by the different nodes. So whenever there is a write request, the if somebody is some node is asking, some process is asking for updating the data, the write request will be accepted by updating the data. And once the data is updated and acknowledged, it is the duty of the central server to send an acknowledgement message to that particular node who has requested for the write operation. Now, in this case, timeout can be used in case of failed acknowledgement. If the server is going to acknowledge any kind of write request, and if it is failed, then the timeout can be used, and uh, timeout can be used with the sequence number, just for the just to avoid duplicate write request, because once a process has made a write request and it has been updated, but the acknowledgement has not been received by that particular node who has made the write request. Even though, so once the acknowledgement is not being received, the process will be again requesting for write. But this can be avoided. The duplicate writing request can be avoided by allocating a sequence number related to the particular write request. Now, it is also possible that in case that a failure condition is arrived, so a failure condition is going to return to that particular application or that particular process which is trying to access the shared data after several retransmission without a response. So there is a possibility of having the failure condition. Now, this algorithm seems to be very simple to implement, but it has the basic disadvantages also, shortcomings also, that if we are using a central server for doing all kinds of services to the different processes, then it will be a bottleneck. So if it is a bottleneck, then the situation may be different. So just to avoid this particular situation, this particular problem, uh, what we can do, we can uh, share the data to the different uh, servers, meaning thereby we are able to replicate the data at the different servers also. But in this particular case, uh, the client who want to access the data, it must be able to locate the appropriate server that where the data is residing. So for every kind of data access, it has to locate the appropriate server if we are replicating we are distributing the same data blocks at the several servers. So one method can be used is the multicasting. The process is going to cast the information regarding the request of accessing the data. But multicasting is not going to solve any problem, because it is again going to it is not going to reduce the load on the server as compared to the central server scheme. So the better way which we can adopt is to distribute data into the partitions. Distribute data is to partition the shared data by the address and use a mapping function to locate the appropriate server. So this is one of the example by which you can say that we have a central server, we have a clients, and the clients are going to access by using the data access request to the central server. So of course, it seems that central server is going to become a bottleneck, but this can be done by replicating the information to the several servers. So this is the central server algorithm. Now the second algorithm is the migration algorithm. So in the central server algorithm, nothing is being migrated. Whenever there is a request from the client, all the things are happening at the server side itself. But so just to overcome the problem which is associated with the central server, because every data access request is to be forwarded to the particular location of the data, while in this particular case, since the migration word has been coming is being coming in this, so it means there is certain migration of the data upon the certain request. So the request is being forwarded to a location to the data, while in this the data is being shipped, data is being taken back to the server, to the client side. So data is shipped to the location of the data access request. So whomsoever, whatever is the address of the data request, the data is being shipped, is migrated to that particular location. And by doing this, the advantageous part of this particular algorithm is that if uh, the process or the client who has requested can be allowed for the subsequent access to perform it locally. Otherwise, in case of central server algorithm, whenever subsequent accesses are required, the process or the client has to go subsequently to the number of times whenever it requires to access the data. But the migration algorithm, the other part of the migration algorithm says that it allows only one node to access the shared data at a time. And the second important part is whole block of the data containing the data items are migrated instead of the individual item request. So there are two things. One is the data is being migrated. It allows only one node to access the shared data, as well as all the blocks related to the data items are migrated instead of the individual item. So there may be a problem of thrashing which can be acceptable, because since in this particular algorithm only one node is allowed, and if multiple nodes are asking for the same data, they have to wait. So that is going to create a thrashing problem. So this thrashing problem can be reduced by using a parameter called tunable parameter, and that determines the duration for which a node can possesses a shared data item, because it will be a limited time for which the data will be available to or migrated to a particular node, and within that particular time it is allowed, that node is allowed to have a subsequent accesses of the information, because when the time is going to be down, the time is going to be up, the duration is going to be end, the data will be migrated from that node to the other node, which is again requesting for the same. So thrashing problem can be reduced by using a parameter which determines the duration for which a node can possesses the information or the data blocks. Now, the migration algorithm, it is providing an opportunity to integrate the distributed shared memory with the virtual memory, provided this virtual memory is being provided by the operating system running on the individual nodes. So when the page, if the page size is going, which is being used by distributed shared memory, is multiple of the virtual memory page size, then locally held shared memory page can be mapped, and it can be mapped to the application's virtual address space, and it can be accessed using the normal machine instruction. So in case that if there is any memory access fault, if the memory address maps to a remote page, a fault handler will migrate that particular page before mapping it to the processor's address space. So whenever it is going to migrate a page, because we know that there are several processes can share a page at a particular node. So before migrating a page is to be removed from all the address spaces with which it was mapped at the previous nodes. Now, to locate a data block that at what particular location it is residing, this migration algorithm can make use of the server that that keeps the track of the location of the pages, or it can use the hints which we have discussed earlier also. It can use hints to maintain the hints to maintain at the node. So these hints can be used to directly the search for a page towards the node currently which is holding that page. So whomsoever is holding that page, that can be identified by using the hint. Other method which can be applied for locating a particular page at the different nodes or the remote nodes by sending a query which can be broadcasted just for getting the location of the page. So this is the kind of a migration algorithm in which the data access is being requested and the data block is being migrated. And since the data block is being migrating, that is why this algorithm is known as migration algorithm. The third one is the read replication algorithm, which is going to uh, add something into the migration algorithm because that is why it is set to be the extension of the migration algorithm. And the purpose of read replication algorithm is to replicate the data blocks, and it is going to allow the multiple nodes to have a read access, or one node to have both read access as well as the write access. Now, what was in the previous case? In the case of migration algorithm, only one node is allowed to work at a time, either for reading purpose or for the writing purpose. But this read replication algorithm is the extension of the migration algorithm, in which many multiple nodes can be allowed to read, to have a read access, or only one node is allowed to have a read oblique the write access. So, but writing is so what is happening? This operation is seems to be expensive because one node which is allowed to access the data for the reading purpose as well as the writing purpose, and if it is going to update, then the if the updation is being there, then the all the copies of the shared block, because many nodes are sharing the same block, it has to do the replication has to be done on all the nodes, either by invalidating or updating the current value to maintain the consistency of the shared data block. So the DSM must keep the track of, are you? So DSM is going to keep the track So DSM is going to keep the track of the location of all copies because it knows that how many nodes has been uh, authorized to access the data block. So uh, it seems to be expensive process, but we can use it. And we can use it if the read operation is more instead of the write operation. So uh, so how to keep the location of the data? How to keep that? How many nodes are having the copies of the data? Either the owner node of the data block keeps the track of all the nodes that have a copy of a data block, or a distributed linked list can be used to keep the track of all the nodes that have a copy of the data block. Now, in read replication algorithm, the distributed shared memory it is must for to keep the track of the location of all the copies of the data block, because if one is allowed to have a write access and if it is updated, all the copies which are available, it should be invalidated and should be updated. Block should be given to all those nodes. But this particular method has the advantage that it has the potential to reduce the average cost of the read operation when the read oblique write ratio is large. If the reading process, if the read accessing is more than the write accessing, then this process can be, then this algorithm can be a better option than the migration algorithm. Now this is the one of the way by which data has been requested by a particular client. It is available at X and it is migrated to that, and it is going to update it, and updation has to be replicated to the rest of the part where the copies of all the shared data is available. So this is the read replication algorithm. And the last one is the full replication algorithm. Now, this full replication algorithm is again an extension of the read replication, which allows, it is also allowing the multiple nodes to have read operation as well as the write operation. Because in the read replication algorithm, multiple nodes are allowed to access the read, but only one, out of that, only one is allowed to have a write access. But in full replication algorithm, both all the nodes are allowed to have a read access as well as the write access. So meaning thereby that multiple nodes can are allowed to write the shared data concurrently, and the access of the shared data, and if it is being done, because it's a problematic part, if multiple nodes are going to write the shared data concurrently, then it is a problematic part. So we have to keep the track, and it has to be done in a very controlled manner, just to maintain the consistency of the information which is being updated by the different node. So the maintaining the consistency in the full replication algorithm is a very important issue. And just to maintain the consistency among the different nodes who have the right access, a sequencer can be used. Sequences can be used. That is called gap-free sequences. So gap-free sequences can be used. And what is in that? All the nodes who wish to modify the shared data will have to send their modification to the sequencer. It is a kind of a controller. So once they will be sending the modification to the sequencer, which will be assigning a sequence number, and then it is going to multicast the modification with the sequence number to all the nodes that have a copy of the shared data. Suppose there are three nodes who want to concurrently have the write access. So before they are going to modify, before they are going to update, they have to ask to the sequencer, and the sequencer will be allocating a sequence number. And once a sequence number is being used by the different nodes, suppose one is given one, second is given second, third is given third. So once first, the one number which has been received by a node, it will be updating, then second will be updating, then third will be updating. And once it is being updated, number one has been updated on the central part, that has to be reflected to the rest. And whenever it has to be reflected to the rest, the sequence number must be followed. So once the sequence number has to be followed, so if there is any kind of miss which has happened, suppose a particular node 7 has received modification which it has received with along with the sequence number 1 and along as well as along sequence number 3, but it has not received due to communication delay or due to some network issue, it has not received sequence number 2 modification, then again it will ask the uh, the server to give the sequence number 2, then only the consistency can be maintained. So uh, as this gap free sequencer can play a very important role in case of full replication algorithm, because all the nodes who are wishing to modify the shared data has to send the modification request first to the sequencer, and the sequencer, as I told you, that it is going to assign a sequence number, and then it is going to multicast the modification with the sequence number to all the nodes which are having a copy of the shared data item. So each node will be processing the modification request in the sequential order as per the sequence number they are going to receive. And a gap between the sequence number as far as the modification requests are expected uh, to a particular node. And if it is so that one or more modification has been missed, in such cases, it will ask the to retransmit the modification which it is going to miss. So it means that there must be a log of the modification which has to be kept at all the nodes, because it is the log by which it will be able to know that what kind of sequence modification it has been received and what is not being received. So this is all about the different algorithm which is used for the distributed shared memory. The first one is the central server, second one is the migration, third one is the read replication, and the fourth one is the full replication. I'm just going to repeat it. In central server algorithm, there is a central server who will be providing services, and since central server is a bottleneck, so it will be problematic. In migration, instead of serving the data blocks from the server side, the data is being migrated to the read access node, and it is going to improve because uh, the central there is nothing like a central server which is existing in the migration algorithm. Then read replication, but the problem with the migration is that only one node is allowed. But in read replication, multiple nodes are allowed to have a read, but one node is allowed to have a write access. So the problem in this read replication that after the updation has been done, the replication has to be sent to all those places where the shared data items are available. And in full replication, all are allowed to read and write, but writing process can be done with the help of a sequencer, in which they are going to ask for the modification, and the sequencer will be allotting a sequence number to the different clients, and based on the sequence number, it is going to multicast the information related to the modification along with the sequence number. And if any sequence number is missing, the client is going to ask for the retransmission. So this is all about the different algorithms.